Mars, first you look for the water. Since life as we know it needs water to exist, you first follow the water, and that gives you a better chance of finding life. And of course, for those of us that are interested in sending people to Mars eventually, water is obviously a very important resource for us. So Phoenix had three primary science objectives. The one I'm going to spend most of the time about this morning is studying the history of water, identifying the water. We also wanted to determine if the Martian Arctic soil could support life, so we had instrumentation on board to look for organic compounds, search for salts, determine the Arctic soil pH, and search for sulfates and any other microbe energy sources that we might find. And then finally, we also had a weather station on board, so we wanted to study Martian weather from a polar perspective since we had never successfully landed in a Martian polar area before. So this is a figure of the hardware. This is the Phoenix Mars lander. We like to say it's the first Mars robot with all 5 human senses. Okay, so it has. So this is the actual lander hardware right here. This is just as it existed back in 2001. These are the solar panels. You have the lander legs. I think you can see some of the thruster jets right here. In terms of the instrumentation, our main camera on board is this right here, the surface stereoscopic imager. And so that's our robot's eyes, right? So that's how we used to see. We have an arm right here. This is our robotic arm. And mounted to that robotic arm is a robotic arm camera. So our arm allows us to go out and touch the surface. We also have 2 sets of in situ instrumentation. In situ meaning we have to introduce samples directly into these experiments in order to make identifications and make a study of the surface. So one of those is the thermal and evolved gas analyzer, which is shown right here. We call it TIGA for short. And we have the microscopy, electrochemistry, and conductivity analysis package, which we call MECA for short. And MECA actually has a lot of different components to it. It actually has a piece hanging out on here, which I'll show you a little bit later. But MECA also has a wet chemistry lab inside of it. So that's where you introduce a sample, you take the robotic arm, you dig up a sample, you dump it either into the TIGA or into the MECA. Inside the MECA is a wet chemistry lab, and so you dump the soil in there and you mix it with water. That allows us to taste the surface. And then once the material's in TIGA, we bake it and we look at the vapors that come off. So that's like our nose. Also on the deck here we have the weather station. So this is the weather mast right here with 3 different temperature sensors. Also the wind telltale, which is sort of low tech. We take pictures of it, and based on its deflection and the direction it's being deflected, we can determine Martian winds and what directions the Martian wind is blowing. And then we also had a LiDAR on board, which is the first time we've ever flown a LiDAR to Mars to land. So this was basically a laser ranging experiment where you send out a pulse of light and then you wait, you count for how long it takes for the light to come back. So you get a ranging information from that. And based on the intensity of the light that comes back to you, you can make some inferences about what the light actually hit. And then underneath the lander, you can't see it. We actually had a descent imager, which was called MARTI, and coupled to MARTI was a microphone. So that was our ear for the mission. Unfortunately for MARTI, it was one of the original 2001 Mars Surveyor hardware, and they found out late in the game, actually while we were cruising to Mars, that MARTI could interfere during the entry, descent, and landing phases of the mission, which is obviously critical. And if anything went wrong during EDL, we were going to have a really bad day on Mars. So MARTI, I think originally they were going to take 20 to 30 images, and then it got cut down to 10, and then it got cut down to 5. Eventually, I think a few weeks before landing, it was still going to take 1 image, and then we just lost our nerve and said, let's not even turn it on. EDL is obviously too important. So poor MARTI went all the way to Mars and never got turned on. Okay, so now I want to go into more detail on some of the key pieces of instrumentation that we use for the water observations. The first one, of course, actually has kind of a random name, or it's sort of, you have multiple choice here for what you want to call it. And these have actually, this camera has all been called this in different peer-reviewed publications and different conference proceedings. So sometimes we call it the stereo surface imager, sometimes the surface stereo imager, sometimes the surface stereoscopic imager. But all of them are SSI, so we just call it SSI for short. And like I said, this is the main imaging workhorse. So we have 4 different camera systems on board the spacecraft. But this is the main camera. Here's a picture of it right here. So it kind of even looks like a person here, the 2 eyes. It has azimuth and elevation motors to provide panoramic imaging capability. So the azimuth motor is right here, so that allows you to turn. And the elevation motor is located right here, and that allows you to rotate about this axis. So we can look about negative 60 degrees down all the way to 90 degrees up, and then do a full pan, 0 to 360 degrees. It also sits on a deployable mast, which is shown right here. And this mast extends the height to about 6.5 feet above the surface. So we have a pretty good vantage point once we land to take a look around and try to understand our landing site. Now this camera it's new hardware, but it was actually based on the Imager from Mars Pathfinder design. And the only real upgrade is we included 2 new Mars Exploration Rover detectors on board. And so that offered 4 times higher resolution than what we had with IMP, and gave us 1024 by 1024 pixels per eye, which compared to the Imager from Mars Pathfinder was only 256 by 256 per eye, and gave us 14 degree field of view in each dimension, so it was a square field of view. And like I said, here are the 2 eyes, and they're separated by 15 centimeters to provide stereo data. And then there are 12 filters that sit in the optical path for each eye, and those filters are designed to help us understand the geology and mineralogy of the surface, as well as make atmospheric observations about dust content and opacity. This is a picture taken by the SSI, a color picture taken while we were building up the spacecraft. It shows some of the color chips that we used once we got to Mars to try to do accurate color rendering of the Martian surface. This is the robotic arm, another key piece of instrumentation that we needed to do the water experiment. So that's shown right here. And this was the 2001 Mars Surveyor arm, so it's one of those old pieces of hardware, but significant modifications were done to it after the fact, and they sort of became a surprise that we were going to have to do this. The first thing was done is it was lengthened, because there was all this concern about you fly all the way to Mars and you dig and dig and dig and you just can't reach. So the arm was lengthened, and also the components were improved. At one point, actually when they did a design review of this after Phoenix was selected, they found there was some plastic in certain parts of this, and so that was taken apart and replaced. But it's constructed out of aluminum and titanium. It's pretty long. It's about 7.5 feet long. And it was spec'd to provide up to 400 newtons of force at the tip here, so at the end of the scoop. But in practice, we only ended up going up to about 160 newtons, but that's still a lot of force to impart on the surface. We like to think of it as a backhoe, because that's kind of what's inspired it, okay? So it has 4 degrees of freedom. This is its shoulder joint, so to speak. So it can move in azimuth, kind of like this, and up and down. And then it also has an elevation motor at the elbow joint, so this is the elbow of the arm. And it also has another elevation motor here, down by the wrist, down where the scoop is. And then it also has another degree of freedom, actually, is this rasp bit. Now this is a close-up of the scoop. So here's the scoop, and you zoom in here, and you can see this rasp bit. And what it is, it's basically like a drill bit. And the intent of it was you could bring this out, and if you really hit a hard surface on Mars, you could use this to try to dig up and release some surface so you could get some material into your scoop. And we also had some extra blades on it. This was the primary blade for digging, and we had some other tines on the back here to try to scrape up some material if we hit a really hard layer. The TECP is the thermal and electrical conductivity probe. That's on the robotic arm as well, but it's actually part of that MECA instrument suite. And this has to go directly into the surface and measures the conductivity of the surface. So since it has to come in contact with the surface, it's mounted on the robotic arm. The other interesting thing about the arm is, because it was intended to actually get an intimate contact with the Martian surface, it had to be sterilized by a quite stringent requirement. And so it had to be baked out, I think it was around 260 degrees Fahrenheit, it had to be sterilized, and then put inside this. This is what we call the biobarrier bag. So this sits on the lander deck, and we tried to keep everything inside there that was going to come in contact with the Martian surface clean, a lot more clean than the already extremely clean instrumentation that was just on the exposed part of the lander. So a lot of care was put in to try to make sure that we weren't bringing along our own microbes or our own organics that we were going to detect once we got to Mars. Kind of funny thing happened though once we got there that I'll show you later. Another key piece of instrumentation is the robotic arm camera. Now this is dear to my heart because this was a big part of my PhD dissertation when I was working for Peter. This is a picture of me sitting with the flight version of it. But it was 2001 Mars Surveyor hardware. So this was done actually around late 1999, early 2000, and just sat on the shelf and ended up not going through any modification. It flew as is, as we finished it at Arizona back in 2000. It was mounted just behind